Welcome viewers, in this video we will see the details about the pointers available in C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic pointers available in the C programming language. First we will see what is the pointer. A pointer is a variable whose value is the address of another variable. So pointer is nothing but that is also a variable, but it will store the address of another variable. So pointer is used to store the address of the another variable. The syntax is data type star pointer variable, right? So it is indicated by star. Star indicates it is a pointer variable, right? We'll see the example integer star p. That is nothing but pointer to an integer variable. So the star p will store the address of the integer variable. Float star fp. So pointer to a float variable. So the star fp will store the address of the floating point variable, right? So pointer is the variable to store the address of another variable. It is indicated by star. Now we'll see the further details. So the star indicates value at the address. Value at address operator. Gives value stored at the particular address. So if you refer the star, what it will return? It will return the address at which what is the content of the address will be given by this star. This AND operator, address operator, it will give the address of the variable. The variable where it is stored, which address, it will give the address. So the star will give the variable, the address at which what is the value is stored. The AND address operator will give address of that variable. So accordingly we can able to use. If we want to get the address or variable value, we can use these two. For that we'll see some examples. Integer x. We declare the integer x, normal variable, integer variable. Integer star pointer. This is the pointer variable, right? X is the normal variable, in star ptr is the pointer variable. X equal to 10. The value 10 is assigned to the x. Pointer ptr equal to address of x. So what will happen? We'll see, right? X is the integer variable, star ptr is the pointer variable, 10 is stored in the x, address of x is stored in ptr. Let us consider the value is 10. The address is 4104. The integer 10 is stored in the address 4104. Now we'll see. So if we refer x, that value of x will be given. If you refer the x in the program, it will return value of the x 10. Star ptr, if you refer star ptr, that also it will give value of the variable x. 10 will be written, right? X will give the value of the x. Star ptr also will give the value of x. The pointer at the address, in that address what is the content, that will be written by this star ptr. This ptr alone, pointer, it will give the address of the variable x 4104. So this address will be written if you refer ptr. So star ptr and ptr, address of ptr means that also will give address of the pointer, right? That is 4108. That is this 4108 is, that is the address of the 4104, right? So that's that tabular column is given here, right? X is stored in 10. X value is 10, that is stored in 4104. The address of x. This 4104 is stored in 4108. That is the address of the pointer variable. This address of the variable x, right? So it is very clear, I think. X is the value 10, that is stored in the address 4104. This 4104 is stored in the another address 4108. So if you refer x, it will return the content of the address 10. If you refer star ptr, that also content of the address 10 will be given. Only pointer if you refer, it will give 4104. Address of pointer means where this 4104 is stored in 4108. So it will give 4108, right? So we can get the value, address, content of the address, or the address, or address of the pointer. All these things we can able to get by referring this. I will go to the next point. So the next is the arrays using pointer. Now we refer the only single variables. If you want to give the set of variable, we are using array. How we are implementing pointer in the array. When an array is declared, the computer allocate a base address and sufficient amount of storage to contain all the elements of the array in the contiguous memory location. We know that array is the collection of set of data. So if we declare the array, the sufficient amount of memory will be allocated in order to store the set of data. For example, integer x of 5. What is the meaning? The x is the variable name, array name. Maximum 5 elements we can store. The type is integer. So this is given. The array elements are given here itself. Open the brace, 10, 20, 50, 45, 200. So these are all the 5 array elements. That is x of 0 is 10, x of 1 is 20, x of 2 is 50, x of 3 is 45, x of 4 is 200. Right. How it will be stored in the memory location? See, this is the element x of 0, 1, 2, 3, 4. The values are 10, 20, 50, 45, 200. So it is located in the address 1000, 1002, 1004, 1006, 1008. So earlier we discussed only one variable, here array set of variable. So this is the how the set of variables are stored in the memory location. Now we'll see how to access, how to refer this. So pointer variable integer star p, right? We declare one pointer variable star p equal to x. What is the meaning? X is stored in p, content of x, that is equivalent to p equal to address of x of 0, right? Address of x of 0, so both are equal. What is the meaning? Address of x of 0 stored in p, address of x of 1 stored in p plus 1. So array is a collection of elements. Similarly, pointer also will be incremented. Address of x of 2 will be stored in p plus 2. Address of x of 3 stored in p plus 3. Similarly, this also address is available. This is address of x of 4 stored in p plus 4. Right? So we can simply refer x equal to p mean address of the array elements one by one will be stored in pointer variable. That is the meaning is this. P equal to address of x of 0. That refers from x of 0 to x of 4. That is, these addresses are all stored in pointer. 1000 will be stored in p, 1002 will be stored in p plus 1, 1004 will be stored in p plus 2, 1006 will be stored in p plus 3, 1008 will be stored in p plus 4. Right? Set of data, set of address stored in the pointer one by one. Right. Now we'll see the function with the pointers. How we can refer the function in the pointer. A function like a variable has a type and address location in the memory. It is therefore possible to declare a pointer to a function which can be used as an argument in another location. We know that function is a user defined set of program, right? Subprogram. Main program is there, function is the subprogram. Some specific task, repeated task can be declared as a function. So we can call the function, we can define the function will return the value. These are all available under function, right? So what is given here in the pointer? So if we declare a pointer to a function which can be used to argument in the another location, right? So another location, function calling, function return, we can use that pointer. The type star f ptr, open and close the brace. This f refers the function pointer. Normally ptr refers the pointer, f ptr refers the function pointer. This tells the compiler that f ptr is a pointer to a function which returns type value. The parentheses around star ptr are necessary. This parenthesis is necessary. right? So what is the meaning? Double mul integer comma integer, double star p1 open and close the brace, right? It is meaning that it will pass the array elements, pass the elements pointer. So p1 equal to mul, right? So mul p1 equal to, this is a pointer variable, is declared here, star pt1. So this is the pointer variable. So this value mul will be stored, that is clearly given here, pointer to a function which can be used as an argument in another location. So here we are passing the argument to this pointer, right? So we'll see the further. Declares p1 as a pointer to a function, mul as a function, and then make p1 to a point to the function mul, right? We know that p1 is a pointer to the function, mul is the normal function operator function. So that make p1 to a pointer to the function. P1 is the pointer to the function. So to call the function mul, we may now use the pointer p1 with the list of parentheses. Star p1 open and close the brace. So this is indicates the function call using pointer. We already discussed opening and closing brace is necessary. X comma y, right? Already p1 is assigned with the mul operator, mul function. So here we are passing x and y. We are calling the function mul using the pointer. So it is equivalent to mul xy, right? So this mul and p1 already assigned. So we can call, this is the normal calling mul xy. This is the calling the function using pointer, right? Similarly, we'll see the structure using pointers. How we are using the pointers in structure? struct, this is the keyword for creating the structure. The structure name is inventory. We know that structure is a set of different type of data that are related data. Array is a set of same type of data. This is different type of data. These are related each other related. That is, it is nothing but inventory, related to inventory. Character name, integer number, float price, then product to star ptr, right? So this is the three variables available in the structure inventory. One is inventory name, inventory number, price. Here we created the structure variables, product to. So it is nothing but structure variable using array. We can store two different data in this. Also one pointer is there, star ptr. So what is the meaning? This statement declares product as a array of two elements. Each of them type structure inventory, right? So product of 2 means, so for example, product 1, product 2, like that we can declare. Otherwise, product of 2 using array. So what is the advantage of array? We can declare n numbers. Here only 2 is declared. We can declare 20, 40, 50 like that, right? P1, P2, P3 means very difficult. Similarly, we can do P product of 100 means 100 data can be stored, 100 set of data. So that is given. And ptr as a pointer to a data object of the type structure inventory. So we are declared with pointer also. Now we'll see how we can use this pointer in the structure. What is the process? So ptr equal to product. Like p1 equal to mul, we assign the function with the pointer. Similarly, this product is now assigned with ptr. So what will happen here? Would assign address of 0th element of product to pointer, 0th element. That is, the pointer ptr will now point the product 0. It is a member can be accessed using following notations, right? Already product of two elements are there. After declaring, product of 0 will be assigned. So product of 1 will be also assigned after increment, 1 by 1. Like that, P1, P1 plus P1, P plus 1 like that. The array, while declaring the array, the pointers also incremented. Here also it will be incremented. So next set of address, product of 1 will be stored. So how we can refer? ptr name, ptr number, the arrow mark, ptr number, ptr price. The next one means we'll go with the product of 1 next time. PTR1, it may be PTR1, 2 like that, right? So this product is nothing but structure variable. Two variables are there, product of 0, product of 1. So that is assigned to the pointer. What is the meaning? The product of 0, now all the members will pointer will point out the product of 0. That is, these three variables are assigned in the address using the pointer. That can be referred using this pointer name, pointer number, this arrow mark. So this is the for loop is there. Pointer product. PTR less than product plus 2. PTR plus plus. Right, already we declared two variables now, so we can open the for loop. Now we'll see the example program for this pointer. So the program working a pointer. How we will come to know the working of pointer. Open the main program. Void main. Open the brace. Variable declaration. Integer star PC comma C. So C is the integer variable. Normal integer variable. Star P is a pointer variable that will store integer type data. The address of integer type data, right? So one normal variable, one pointer variable. After clear screen, we go to the three different sets are available. First one is C equal to 22. We assign 22 to the variable C. Now we are printing print of address of C percentage D, that indicates integer. Slash n mean it will go to the next line. Address of C. We know that address of C mean it will print where this 22 is stored. It will give the address where it is, this 22 is located, address of C. Printf value of C percentage D slash n integer type, go to next line. C means it will refer 22, right? So value of C mean it will print the value 22. Address mean it will print the address. So C refers value, address of C refers where the C is located, that address will be written, right? Now we'll go to the next model. C equal to address of PC equal to address of C. So this is a pointer variable. Address of C is stored in PC. Now we'll print address of pointer PC is what it will give. So at the PC contain address of C, right? The C is located in one address, that address is stored in PC. So it will give the where it is located, very similar to and C, right? Content of the pointer PC, star PC. So if you refer star PC, what will get? Will get the value, the address in which what value stored. Very similar here. So we are using different notation. And C give address of C where it is located. C will give the value. Star PT also will give the value. PC means it will give the address. After this statement, PC equal to and C, so that address of C is available in PC. While referring PC, we are getting address, right? And then C equal to 11. Now we are assigning C equal to 11. Printf address of pointer PC. Here we'll get the previous address only, because already address of C is printed. So where this C is available, that address will be printed. Content of pointer PC, this, that also it will print 11 only. Now the content of C is 11, right? So there are three different process. We process the three different methods. So add and C will give address, C will give value, PC will give address because we store the address here. Star PTR will give address, will give the value, this will value. PC will give the address. Star PC means this value, because now 22 is overwritten by 11. After get CH, we can close the program. Now we'll see the output for all the cases. So the first case, address is printed, then value is printed 22. Second case also address is printed and value. Third case also address is printed. Now the value is changed to 11, because initially we store 22 in C, then it is changed to 11, right? So and C will give the address. PC pointer variable will give address, and C normal C means value. Star PC means value, right? So that is the already we discussed, so that is we now executed with the program also. So in this video we discuss pointer available in the C program. What is the pointer, what is the definition, how we can use this pointer in array, structure and functions, and we discuss one sample program also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the dynamic memory allocation available in the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic dynamic memory allocation in C programming language. The process of allocating memory at runtime is known as dynamic memory allocation. So during the runtime we are allocating the memory, that's why it is called a dynamic memory allocation. Now we'll see what are the functions available under dynamic memory allocation. The first one is malloc, M-A-L-L-O-C, malloc, that is nothing but allocates required size of bytes and return a pointer to the first byte of the allocated space. So memory allot, this malloc is called memory allot. So it will allot the size, required size of bytes. Then it will go to the pointer. So while using the dynamic memory allocation, we need to declare pointers. The pointer will go to the first byte so that we can store the data in the first byte, thereby second and third byte, so that the pointer return to the first byte. Then calloc, allocate space for array of elements. This is malloc. We don't know the size, but here is given the for array of elements. What is array? Array is the set of same type of data. Integer A means integer type. We can store one data. Integer A of 10 means a single dimensional array. With the name of A, we can store 10 different integer data. That is A of 0, A of 1, A of 2, like that. We can store 10 data. So the array, for allocating the memory for array, we are using calloc. Initialize them to 0 and return a pointer to the memory 0, because array starts with 0. A of 0 is the first element, right? Then go for the remaining. What are the remaining memory allocation, dynamic memory allocation functions are available? Free, previously allocated space. So here by using malloc, calloc, we allocated the memory. By using the function free, it will free the allocated memories. Realloc, so already allocated, it will modify the size of the previously allocated space. By using malloc, calloc, we allocated. If any modification is there, we can use realloc. Then malloc, this example how to use the malloc. Pointer, cast type, malloc, byte size. Cast type means, so the example available here, x equal to, this pointer is x. Integer, we are going to use integer, malloc, 100 into size of integer. So what will happen? So it is the integer type. How many data we need? 100. So 100 into size of integer. For an integer, some size is available. 100 times it will allocate the memory, that is indicated by the pointer x, right? So here we are allotting 100 memory space for storing the integer data type, right? For example, the size of integer may require 2 or 4 bytes. So 4 bytes into 100 space will be allocated. Then calloc, how to allocate the calloc? Pointer, cast type, calloc, n, element size, right? Element size. For example, it is a integer or floating point. What is the size of the integer? How many array elements are you are using? 100 or 10. That is indicated by n, right? Then free is very simple. Free pointer. So this pointer is already allocated. Free pointer means the already allocated memory will be free. Already allocated memory will be freed. It will free the memory space. Realloc, pointer, realloc, pointer, new size. So already allotted size is there. If you give the new size will be allotted in the same pointer, right? So we have malloc, calloc, free, realloc, 4 pointer, 4 dynamic memory functions available. We discussed this. Now we'll see one example program for further understanding. So the program to calculate sum of n numbers entered by the user using dynamic memory allocation. The program, simple program, sum of n numbers using the dynamic memory allocation. First we'll start the main program. Void main, open the brace, integer n. N is the n number, how many number we are going to use. We need a for loop, so we are declaring I. This pointer, we already discussed, while using the dynamic memory allocation, we need pointer type data, star ptr, so integer type. Sum equal to 0. We are going to add n number of n numbers into, we are going to add, first initially we'll keep sum equal to 0, thereby we'll add the numbers one by one in this variable sum. So this is number of elements used for loop. In order to use the dynamic memory allocation, we use star ptr. The final answer we are going to in sum, that is we declare 0. First we'll ask the user to enter the number of elements. Printf enter number of elements. Scanf %d and n, right? Address of n. %d refers integer type. Then and n address of n. The number entered by the user will be stored in n. Now we'll go for the memory allocation. How to allocate the memory. Pointer, we already declared pointer. We know that is a integer star, malloc, size of integer. How many integers are needed? That is given by n. If n equal to 5 means 5 into, 10 means 10 into. So that number of size of integer is allocated. This malloc is used for allocating the memory, right? If memory cannot allocated, we need to check. If pointer equal to null, that means suppose the n is very large or some other error is there, the memory is not allocated. So that is verified here. If pointer equal to null, double equal to mean it will check. Printf error, memory not allocated, exit. The program will be completely exited, right? Due to some error or large number of memory, sometime memory will not be allocated. That is, we can check the pointer. If it is null, mean memory is not allocated. Otherwise, we can continue the program, right? Now the memory is allotted. We check the memory also. It is not a null. If it is null, it will exit the program. Now we ask the user to enter the elements. What are the elements to be added? So n number of elements available. So we are open the for loop. For I equal to 0, I less than n, plus I. Scanf %d pointer plus I, because the elements are stored in pointer, right? So initially I equal to 0, pointer plus 0, that refers first element, right? Sum equal to sum plus star ptr plus I. The first element entered is added with the sum stored in sum itself. Sum is already 0. So what are the element we entered, that will be added. 0, for example, 10 means 0 plus 10, 10 will be stored in sum. Now sum become 10. Earlier 0, now 10. Then it repeated. For example, 10 numbers means it will last 10 times. So all the numbers what we are entered is added with the sum, cumulatively added. This I is incremented because of increment operator. Initially pointer plus 0, first number, pointer plus 1, second number, pointer plus 2, third number, like that it will execute. So after executing this for loop, all the sums, all the numbers are added. That can be printed. Printf sum equal to %d sum. The added values is printed. Then we can deallocate. We already allocated the memory. Deallocating the memory. Free pointer. So already allotted memory will be freed. It will be free the memory space. Then close the program. So in this video we discuss dynamic memory allocation. Allocating the memory during the running time. There are 4 functions available. We discuss the 4 functions. Then we discuss one example program. Sum of n numbers using dynamic memory allocation. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the file handling process in the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, file handling in C program. So we know that file handling is used for storing the data. So every time while running the C program, we need to give the inputs. According to the input and program, we'll got the output. But some data we can permanently store in the file. Whenever we need, we can retrieve the data, and also the output also can be stored in the file. So for this process, we are going for file handling in C program. C supports a number of functions that have the ability to perform the basic file operations. We'll see what are the operations. Naming a file. We can name the file. Opening a file. In order to read the data or write the data, first we need to open a file. Reading data from a file. We can able to read the data from the file. Similarly, writing the data to a file. Once the file is open, we need to close a file. So we can name the file, open the file, we can read or write, then we can close the file. So for that we are having the high level input output functions are available. In order to open, close, read, write and other operation, the IO functions are available. We'll see these IO functions one by one. First one is F open. This F refers the file. Create a new file for use or open a existing file for use. Right? We can create the new file. Otherwise, if the file is already available, that also we can open by using the function F open. F close. Close a file which has been opened for use. Once the file is open, we have to close. F close. Get C. Get C means read a character from a file. Put C. Write a character to a file. Only character. Right? Get C, put C used to read a character or write a character to a file. F printf. We know printf means it will print the data on the monitor. F printf means write a set of data to a file. Right? Normal printf write the print in the monitor. This F printf means write the set of data to a file. Similarly, F scanf. F scanf means it will scan the data from the user through the keyboard. F scanf means read a set of data from a file. Right? So F printf, F scanf refers the file. We can read the data from a file or write the data to a file. Some more functions are available. Get W. Read a integer from a file. We already see get C, put C, that is used for character. Similarly, get W, put W. Read integer from a file. Put W means write an integer to a file. Right. This refers the integer. Earlier one character. Then seek. Set the position to a desired point in the file. Right. Desired position it will set. Either beginning, at the middle, like that. So once you open the file, the current position at the beginning. Once the data is keep on writing the data, the cursor position will be available at the last. So if you want to move the data, we want to move the position from in between or beginning or the end, we can use the seek. The separate detail available for a seek function. In that so many subdivisions are there, that is available in separate video. F tell. Give the current position in the file. Right? So while writing the data one by one, it will write currently at the last position. If you read the data, it will go again somewhere else where we are read. So where the cursor is currently available means we can use the function ftell. So it will give the current position in terms of bytes from the start. It will give the bytes. Then rewind. Set the position to the beginning of the file. Whatever may be, if you want to start from the beginning, you can use the function rewind. So it will set the position at the beginning. Right. So what we have, F open, F close. Opening the file, closing the file. fprintf, fscanf. Normally read the data, write the data to a file. GetC, putC refers character. GetW, putW refers integer. Seek means it will set the position. Ftell means current position it will give. Rewind means it will go to the beginning. Now we'll see one example program for this file handling function. Program C program to read name and mark of n number of students and store them in a file. So by file handling, what we are doing, we are going to read the name and mark of n number of students from a file and we are going to store in the file itself. Start the main program, void main, open the brace. First declare the variables. Character name 50. So this refers the name of the student. The number of characters is 50. Integer mark I num. I refers used for loop, num refers number of students. Then clear the screen. Now we can read the data from the user. Enter number of students. Printf enter number of students. So the user will enter the number of students. That is used by scanned by scanf. %d and num. And %d refers integer type. And the number means address of number. The number entered by the user will store in address of number. Now we will able to know how many students. Number is we read from the user, number of students. Now in order to process the file, first we have to create the file pointer. File star fptr. So this is a file pointer. The file opening, closing, reading, writing, everything possible only after creating the file pointer. Now star fptr is the file pointer. Now we have to open the file. In order to read or write the data, open the file. fptr. Now always we refer the file pointer. Equal to fopen / student.txt. This is a file name. At : it will store with the name student.txt. W means we are opening the file for writing purpose. If file pointer equal to null, we have to check whether this any error is there. We have to check the null position. Printf error and exit. So thereafter not possible to process if it is null. File pointer is null. Otherwise we can proceed. Now we'll see how to write the data. For I equal to 0, I less than num, I plus plus. We start from 0. This is the number of students. One by one we have to store where incremental I plus plus. Starting value, condition, final value in increment. Printf for student / enter name I plus 1. So what is that for the student? This is percentage means it will refer I plus 1. I is 0, 1. 0 plus 1 means 1. For student 1, here it will print 1. Enter name. So scanf %of name. Right? This percentage here refers I value. I value is 0. I plus 1 means 1. So it will read the first student name. Then enter mark. Scanf %d and mark. So it will read the mark. So first student name and mark is read from the user. Now we can write these two data in the print in the file, not a print. Normally we'll print, but we are going to print the data in a file. So fprintf. Fprintf, you have to refer the file pointer, fptr. Name, : what is the name? %s. Next line, mark equal to %d. Next line. So this %s refers name. Here the name will be printed. %d refers integer type, mark. The mark will be printed one by one. Next line. Name, it will print the name. Go to next line. Mark, it will print the mark. So the same process repeated until number. Suppose the user enter number equal to 5 means 5 times this process will be executed. So all 5 data, name and mark, will be stored in the file itself. Right. Once we open the file, we have to close the file. Close fptr. For every operation we are referring file pointer. Then close the program. Right. So in this video we discuss the file handling functions available. Open, close, read, write. Then we discuss one program, example programs to store the student name and mark of n number of students. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the defining and opening, closing and processing of file in a C program. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, defining one opening a file. In this video we are going to see the file handling in C language. How to open the file, how to define the file, how to close, what are the input output operations available. Defining and opening a file. First we need to open the file. So first we have to declare the file pointer, where all the operation refers this file pointer. After creating file pointer only we can open or close the file. So file star fp, this refers the file pointer. Fp equal to f open, we are going to open the file. File name, you have to specify the file name here. Then mode, whether we are going for read or write or append, right? So this detail available here. So file pointer, file open, file name, mode. The mode is nothing but if you give R means open the file for reading only. W means open the file for writing only. A means open the file for appending or adding the data, right? So appending means already available data, it will be added. If it is only with the read, it will read the data. If you open with the write, already available data will be overwritten. It will not keep the earlier available data if you open W. If you open A, then only available data will be kept as it is. New data will be added together. So that is the difference between W and A. So R means read the data. W means write the data. Earlierly available data are erased. A means earlierly available data kept and new data will be added. So according to our requirement we can open, right? So here the example available. File star P1 star P2. Two file pointers are created, P1 and P2. P1 equal to f open data. File name is data R. So it is created for writing the data. F2 open, f open result. The W, that is means it is used for writing the data, reading the data and writing the data, right? So according to the requirement we have to specify the mode of operation. Then we'll go for a closing a program, closing a file. Once the file is open, it must be closed. F close file pointer, F close P1, right? Once the file is open, it must be closed, then only it will go to the beginning of the file, right? File close. Then we'll see what are the input output operations available. Put C comma file pointer. It is used to write a character contained in the character variable C to the file associated with file pointer P1. So it will write the characters to the file. Similarly, get C is available. It is used to read a character from a file that had been opened in the read mode, right? This refers the file pointer, get C refers read the character, put C refers write the character. Now we'll see one example program for this file handling, opening, closing and writing the data. So C program to read name and mark of n number of students and store them in a file. The program is to read the name of the student and mark of the student of n number of students that will be stored in a file. First we can open the main program, void main, open the brace. We can include the header file, that is default, stdio.h, conio.h, standard input output header file, console input output header file. We have to include, that's not given here. Then we have to declare the variable. What are the variables we need? We need name and mark. Name is coming under character. Character name 50. So 50 character can be stored. This is the name of the student. Integer. Mark is coming under integer type. You can store the mark here. I, comma number. I refer for loop because n number of students are there. We need to open the for loop. Num refers number of students. How many number of students are available. First we ask the user to enter the number of students. How many number of students? Scan of %d and num. %d refers the integer type. And num means address of number. The data entered by the user will store in address of number. Now we are able to know how many students are available, num, because the user entered the num value. Now we'll create the file. In order to write the data, first we need to create the file pointer. File star fptr, file pointer, right? So all this operation, opening, closing, adding the data refer with the file pointer. So fptr equal to fopen, we are going to open the file. C colon student.txt, this is the file name. At C colon it will store. W refers, it is used for writing purpose. We are going to write the data. Similarly, we have reading the data, appending the data, what we discussed earlier. Now if any error is there, that must be verified. If file pointer equal to null, print of error and exit. We cannot proceed if any error is available. If the error is not available, we can proceed. What we need to do, we have to get the student name and mark from the user, and that should be stored in a file. So for that we are opening the for loop. For I equal to 0, I less than num, I plus plus. Initial value 0, this is condition. If the number is 5 means we have to execute 5 times. I less than 5 is increment, right? So initially we'll keep I equal to 0, that refers first student value. Print of for student %, next line, enter name. What is this %? This %, this is a %d. This refers %d, that is I plus 1. I value is 0, I plus 1 means 1. So for student 1, it will print 1. I is 1 means 2, 2 means 3, like that it will print. Then the user will enter the name, scan of % name. The name entered by the user is stored in the name. Then print of enter mark. Then user will enter the mark, %s and mark. %d refers integer type, address of mark. Now we got the student name and mark of a first student. Now we can write these two data in a file. fprintf. Fprintf means we are going to print the data in a file. That's a fprintf. File pointer. Always we have to refer the file pointer. Name is %s. Next line. Mark %d. Next line. What happened? Name. It will print the name here. %s means it will print the name. It will go to the next line. Mark equal to %d. It will print the mark and go to the next line. Then again it will process. Go for the next process. I incremented. I become 1. Then again he got the mark and name of the second student. The process will continue until the condition failed. So for example, 5 means it will execute 5 times. So 5 student name and mark will be stored in a file. Then it will close the program for loop. If the file is open, you have to close the file. Close, pointer, fptr. Then only it will go to the beginning. Then close the program. So in this video, we'll discuss file handling in C program, how to define a file, what are the modes available, read, write, append, how to close, what are the file processing, reading and writing. Then we discuss one example program. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the error handling during I/O operation of file handling process, C programming language. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, error handling during I/O operation for file processing in C programming language. I will see what are the functions available for error handling. FEOF. The FEOF function can be used to test for an end of the file condition. We'll check whether we reached the end of the file. While reading the data or writing the data, we can identify whether end of the file. End of the file means thereafter there is no data. So we can able to identify end of file by using this function. F_error. The F_error function reports the status of the file indicated. Right? Whether there is any error occurs, that will be given by F_error function. Then random access to the function file. What are the functions available to randomly access the file? Normally we have file open, file close, file read, write. These are all the functions already available. Apart from that, random access to the files are available. Ftell. Ftell takes a file pointer and return a number of type long that corresponding to the current position. The current position will be given by ftell. N equal to ftell fp. Fp is the file pointer. So the corresponding file, the name, what is the number, current position, that will be given by ftell, that is stored in the number n. Right? So it will give the current position. Rewind. Rewind takes a file pointer and reset the position to the start of the file. Rewind means whatever may be the current position, the position will go through the start of the file. It will go for beginning of the file. Rewind fv. So it will go to the beginning. Then one more function, fseek. Fseek function is used to move the position to a desired location within the file. We can go to the desired location according to our requirement. We can move. The syntax is fseek file pointer offset position. So this is a file pointer, corresponding file pointer we have to mention. Offset, then position. What is offset? 0 means it will go to the beginning of the file. 1 means current position. 2 means end of file. What is the offset? Positive, moving forwards. Negative means moving backwards. Right? So according to the desired location, we can go by using this. Offset gives moving forward or backward by using positive and negative. These values give either beginning of the file, end of the file, or current position. Now we will see what are the possibilities, what are the further functions available in fseek. So various operations performed by fseek function. First one, fseek file pointer ol, 0. Go to the beginning of the file, very similar to rewind. Right, 0, that refers beginning of the file. F6 fl ol 1, it will go stay at the current position. 1 is the stay at the current position. F6 fp ol 2, go to the end of the file, pass the last character of the file. Right, so 0 means the beginning of the file, 1 means current position, 2 means end of the file for ol. Right, same. F6 fp m,0. M,0 means beginning. Right, so move to the m+1 byte in the file. M, you have to mention the value. 10 means 10 plus 1, it will go to 11th position, 11th byte, like that. Right, so what is the number here specified here? That byte will be moved by this function. Now we will see some more functions available. F6 fp m,1, go forward by m bytes. Go forward, 1 refers forward. F6 fp minus m,1, go backward by m bytes from the current position. Right, so m, we already know that it will go to the m+1 byte. 0 means it is at the particular position, m+1 position. 1 refers, this 1 refers go forward. Minus m, 1 refers go backward. Right, f6 fp minus m,2. Right, minus m, 1 means backward. Go backward by m bytes from the end. Positive the file of the mth character from the end. Position the file to the mth character from the end. Right, that is the difference between these two. These both are backward, but the mth position from the end of the character it will position. When the operation is successful, MC return a 0. Error means return -1. So by using if condition we can check whether this FC operation is successful or not. If it is 0, it is successful. If it is -1, that is a error. So in this video we discuss about the random access to the file and error handling, and also various operation of fseek function, beginning, end, at current position. These are all discussed. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the string handling function available in the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic, string handling function in the C programming language. First we'll see what are the string handling functions are available. First one, strlen, that is string length, used to find the length of the string. So this function, if you specify the which string you want to find the length, if you specify here, it will give the string length, how many characters are available. strlen will give the string length. strcat, that is string concatenate. We can give two strings here. The two strings will be concatenated. Concatenated means added together. Used to concatenate two strings. For example, welcome today. If you give two strings, it will combine both the string. Welcome today. Right? String concatenate will concatenate the two strings, two or more strings given within the bracket. strcmp, string comparison. It will compare the two strings specified in the bracket, used to compare two strings. So it's case sensitive. It will identify small letter and capital letter also. It's a case sensitive, right? strcmpi, the same thing, string comparison, but this is not a case sensitive. For example, small a and capital A can be treated as the same, but here different. It's a case sensitive. It will check the case also, small letter or capital letter. Right? strcmp, string comparison with case sensitive, strcmpi, string comparison without case sensitive. Right? strcpy, string copy, used to copy one string to another. Right? Here we can specify two strings. For example, string 1, string 2. The content of string 2 will be stored in string 1. The already available content in string will be overwritten. Right? So the content of second string will be copied in first string. Already available content in string 1 will be overwritten. But here string concatenate is not like that. Both the strings are added together, not overwritten. Or for example, string 1, string 2 mean both are added together. String copy mean content of the second string will be stored in first string. That is the difference between string concatenate and string copy. I will see some more string handling function available. strlwr, that is string lowercase. The string specified here will be converted into lowercase. This function converts all the characters in the given string from uppercase to lowercase letter. Right? It will convert everything into lowercase. strrev, the string reverse, used to reverse the characters in the given string. Welcome means it will completely reverse the characters. Right? strrev, string reverse. strupr, string uppercase. So this one lowercase, no? Similarly here uppercase. This function convert all the characters in the given string from lowercase to uppercase letter. Right? So it will convert from lowercase to uppercase. Whatever may be, final answer will be uppercase. So these are all the string handling functions available. First one is string length. It will give the length of the string. String concatenate, adding two strings. String copy, one string is copied to another string. Then string comparison with case sensitive, without case sensitive. Then string lowercase, uppercase. Then string reverse. These are all the functions. Now we'll see one program example program so that we are able to understand clearly. Program to perform string handling functions. Program to perform string handling functions. First we'll include the header file. Has include stdio.h, standard input output dot header file. It is used for printf and scanf. Has include conio.h, console input output dot header file. It is used for getch and clear screen. For that we are including. Then start the main program. Void main. Open the brace. We'll declare the variable. First step is declaring the variable. Integer n. So in order to store the length of the string, we are declaring one variable. String integer n. Then character. We are going to declare 4 strings to perform various string handling function. We are declare 4 strings with 30 characters. str1 30, str2 30, str3 30, str4 50. So first 2 30 characters, third and fourth 50 characters. That is our choice. This 50 and 30 is the maximum character. We can use less than 30 also, right? So the 30 memory space will be allotted, but we can use within 30. Then clear screen. Then we ask the user to enter the first and second string. Printf, enter first string. Scanf percentages str1. The user entered the first string is stored in str1. Then we'll go to the second string. Printf, enter second string. Gets, the string can be, this scanf is the one type of function to read the character from the user. The gets also used to read the character, string character from the user. Gets is very similar to scanf. str2, right? String 1 is scanned by scanf function. String 2 is scanned by gets function. Now we'll use the first string handling function, strlen, string length, bracket str1. So it will return the how many letters available, characters available in string 1. That will be stored in n. We already declare n is the integer type, right? So the number of characters will be identified by this string handling function, string length, that will be stored in the integer n. Now we'll go to the next handling function. Then immediately we are printing length of the character. Printf, length of first string is %d n. This %d refers the integer type, right? So we identify the string length of str1 using strlen function. That answer available in that is printed. So we got the answer length of the first string. Now we'll go to the second function, strcat, string concatenate. str1, str2. So it will concatenate the string 1 and string 2. Both are added together. The answer will be stored in string 3. We already declared 4 strings, right? So string 1 and string 2 are added together. That will be stored in string 3. Printf, concatenation of string is str3. So immediately we printed the concatenated string. For welcome today, str1 contain welcome, str2 contain today, means both are added. Welcome today, that is stored in str3, that is printed. Concatenation of string is welcome today, right? Now we'll go to the next one, strcmp, string comparison. String comparison with case sensitive, right? It will check the case also. str1, str2, double equal to 1. What is the meaning? If both the strings are equal, it will return 1. Otherwise, it will return 0, right? So we are checking that is equal to 1. What is the meaning? If it is 1 means printf, 2 strings are equal. Else, 2 strings are not equal, right? The return of the function is both are equal, mean it will return 1. Otherwise, 0. So we are checking whether we are getting 1. 1 means equal, else or not equal. This is case sensitive. Now we'll go without case sensitive. strcmpi. One more character, one more string handling function is available. So here also we are checking 1. 2 strings are equal, otherwise 2 strings are not equal. So the difference between previous one is case sensitive, CMPI is not case sensitive, right? Now we'll go to the next string handling function, strcpy. str4 comma str1. What happened here? The content of string 1 will be copied to content string 4. Right? It is not concatenate. It is copied. String 4 will be copied in string 1 will be copied in string 4. Right? strcat means both are added together, concatenated, but here only copied. Immediately we are printing the fourth string. Print of string 4 is string 4. String 4 is nothing but content of string 1. Right. Now we'll go to the remaining string handling functions. Lowercase. Print of lowercase string is percentages strlwr str1. What happened? The string 1 is converted into lowercase and is printed. Sometimes it may contain uppercase or lowercase. Whatever may be, the final answer will be lowercase. Similarly, uppercase string is percentages strupr. It will convert into uppercase. String 1 is converted into uppercase. Right. Reverse string is strrev string 1. So the content of string 1 will be reversed and it is printed. Right. This is a lowercase, uppercase and reverse. After get ch we can close the program. So in this video we discuss what are all the string handling functions available, and with example program. We analyze all the string handling function with the example program. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.